Okay, this is the second part of the video for H15D, H15E. The second part, we're going to talk about transition matrices. This video, I think we're going to spend a little more time because I think Pablo explained it really well, but there's a couple of key things that I think you need to be very careful with. Now, when we're doing adjacency matrix, this is just to recall, if we start at A and go, we're ending here. So let's just say I want to start at A and end at D. I'd be going here and ending at D, and there's like one path going that way. Okay, so but now we're going to talk about transition matrices. So the rows and columns of the transition matrices are reversed. So what does that mean? So with a transition matrix, we're going to be starting here and ending here. So for example, if I'm starting at A and going to B, I would go here. Versus over here, if I was starting at A and ending at B, I would be here. So just this is a key thing to keep in mind. Okay, so now we have to look at the arrows here. If I'm starting at A, notice how it goes. I'm looking at the arrows. It goes this way, and this way. So there's three paths when I'm leaving A, going out of A, the pink paths. So transition matrices, we use probabilities. So if we're using probabilities and there's three paths leaving, these values are going to be 1/3. Now, Pablo explained this pretty well, but I think the color scheme that I'm using here should help. So like, for example, if I'm leaving B, I've got two arrows leaving B. So I've got two arrows leaving B, so that means the probability is going to be 50/50. Okay, there's only one arrow leaving C. That's why this value is 1. Leaving D, there are two arrows leaving D. That's why these values are 1/2 in the green. So I hope my color coding helps you figure this out. And then question B, he pretty much explains it. So if we're the probability starting at A, ending at D, and she travels along 3 trails, so I have to have this to the power of 3, starting at A, ending at D. This is the value we're looking at. Okay, Pablo explains that pretty well, but I think my color coding is helpful. He explains this pretty well. Now, if you are having difficulty using poly simultaneous program on your calculator, don't worry about it at all, because seriously, all they really want to know is, are you able to figure out when t goes to infinity and we just try a big number. But on the IB test, they may want you to attempt to write this as a system, and then you already know the answer is going to be up here. Okay, so if you're not able to solve the system, don't sweat it. Okay, you might want to hit pause. Pablo explains this pretty well. I read it a little differently, but it's pretty much the same thing. Okay, so you can read this on your own. Okay, now this is an example from the textbook. Pablo does not talk about this. So let's see how I set up the matrix. Okay, so starting at A, there are 3 paths that leave A in pink. So I've got my 3 paths, 1/3, 1/3, 1/3. Starting at B, there's only one path that leaves B, so we've got 1. From C, there are 2 paths that leave, so that we've got 1/2. From D, there are 3 paths that leave D. I've got 1/3. From E, there's only one path that leaves. I've got 1. From F, there are 2 paths. I've got 1/2. So pretty much the way I've highlighted it, if there's something I haven't highlighted, then I would have made a mistake here. So I think the highlighting really, really helps. Okay. Of course, on the IB test, they don't allow you to use highlighters. I think that's really stupid, but okay, well. It's too bad. I'm sorry. But at least this will help you understand. So what did I do? I just put in this matrix into my calculator, and then I did it to a very high power. And then we got the answers. If you're not sure how that works, watch Pablo's video. Okay. All right. Reflection. You can read this on your own. Okay. Question 15E. Check your answers. Okay. Question 3. Check your answers. Check your answers. That's it.